Hi everybody, good morning. Sorry I'm so sick today, you can probably hear it in my voice. So I threw together this little video for you so that you could go through the 9.3 sequences notes, and then hopefully you can attempt the homework and be good to go when I get back. So I already have some things written in, but I just wanted to go through them with you. So arithmetic sequences, as you learned on the first page, are when consecutive terms have a common difference, aka it's just a pattern of adding or subtracting. There's a couple different ways we could write these sequences, and we're going to get used to the notation today. So a sub 1, a sub 2, a sub 3, that just means like the first term, the second term, the third term, all the way to a sub n, which is this like ambiguous nth term. We also could write arithmetic sequence like this, where we have the first term, and then the first term plus one common difference, and then the first term plus two common differences, and D always represents common difference. So some quick examples of these, I feel like these are pretty simple. Let's go like 3, 5, 7, 9, and it could keep going. So like our first term would be 3, and then our pattern is plus 2, so our common difference would be 2. We could also have a pattern of subtracting, so 20, 10, 0, negative 10, kind of keep going that way, where our first term is 20, and then our common difference is negative 10 because we're subtracting. So, different things. Our second term would be 10, our third term would be 0, kind of all that good stuff. Down here is the formulas. You do want to have these written down. I am going to highlight them in yellow because they are important. At any point, if you need to pause and write stuff down, please do so. I just kind of wanted this video to be a little snappy. But here it is. So the recursive formula has to do with the term before it. So that's what that means. So we always establish whatever the first term is in the recursive formula. So like in this example, it would be 3, right? And then this means the next term is the term before it plus 3. So it's just kind of a pattern that builds on itself. An explicit formula, we could put in any value for n and calculate our output. So if we were trying to find the 30th term, we could plug in a 30 for n. We're having numbers in for the first term and the common difference and figure it out there. Okay, so this next example, I do have it filled in already. Our pattern is minus 8. And so the recursive formula, we would have, go there. The recursive formula, we always set the first term. The first term is A119, or A sub 1 is 119. And then our recursive formula would be A sub n equals A sub n minus 1 minus 8 for all n greater than 2, because recursive doesn't work on the first term because you don't have a previous term. And then lastly, the explicit formula. We know the first term, we know the common difference, so we're kind of just plugging in from there. And there we go. So if we're trying to find the 50th term of the sequence, we'll just plug that right into the explicit formula for n, and we get negative 273. All right, I'm going to do this last problem with you guys because this one's a little bit more complex. It says the 11th term of an arithmetic sequence is 29, so we know a sub 11 is 29. And then the 26th term is 134. It says find the explicit formula for the sequence. So the issue with this problem is we need to find the first term and we need to find the common difference. So that's what we're trying to figure out. So I'm going to write two little equations that have to do with the two terms that they gave me. So I'm just going to kind of fill in what I know. I know that 29 is the value of the 11th term, and I get that by doing the first term plus 10 more common differences. And then 134 is the 26th term. I get that by doing the first term plus 25 more common differences. So I'm kind of creating a system of equations here. So what I can do, first things first, is I'm going to find D. I can find the common difference here. And we're going to solve this system using elimination. So I'm going to do, I like to put the bigger one on top. So let's do that. We're just going to stack them. And then we're going to subtract the 11th term equation. So when I subtract, that'll cancel. I have 134 minus 29, that's 105. And then this is 15D. When I divide the 15 over, that's going to give me a value of 7. So there we go. Once I know that, I can kind of just plug it back in to kind of any of these to figure out the first term. So to do that, I'm just going to take this equation and plug in 7 for D, for our common difference. And you get, 29 equals a sub 1 plus 70, so it comes out to be negative 41. So now we can write our equation. Our goal was to write the explicit equation. We have everything we need. This is going to be a sub n equals our first term, negative 41, plus 7 times n minus 1. So then from there, it just says find the 31st term. So I'm just plugging that in into my explicit equation that I made. And then that comes out to be negative 41 plus 210, and that's 169. There we go. Arithmetic sequences, adding and subtracting. Feel free to pause if you need to write more. All right, geometric sequences. We're going to keep things moving. Geometric sequences are a pattern of multiplication. So that pattern is called a common ratio. So it's just being multiplied by something. So here's kind of how we write it. Notation stays the same. We could write the first term, and then the second term is just the first term times r. And then the third term is the first term times r, and that stacked multiplication just kind of builds on itself. Some quick examples here. We could do, 5, 15, 45, and kind of just keep going that way, where our first term is 5, and then our common ratio is times 3, so it's a pattern of times 3. We also can have a sequence of alternating signs, and that's if we have a negative r value. So like we could have 2, negative 4, 8, negative 16, and kind of keep going like that. That would be a first term value of 2, and our ratio would be times negative 2. So there we go. So if r is negative, our sequence will be alternating signs. Here's the explicit formulas. I'm going to be highlighting them because they're important. Recursive, that's our first term, and then it would be the next term is the previous term times r for any n greater than 2, and then here's our explicit formula. So that repeated multiplication is represented with an exponent. All right, I do have this first example written in. Our common ratio, instead of saying divide by 3, we would say times 1/3. The first term is 162, and then it would be the first term, or the nth term times the previous term times 1/3 is how we write our recursive. And then here's our explicit formula. We have the first term, 162, times 1/3 to the n minus 1 power. To find the 11th term of the sequence, I'm just going to plug in 11 into my explicit formula and get that there. All right, this last one is actually just like the last problem that we did. So if you want to pause it and try it yourself, we're going to create a system. So for b sub 7, we're going to create an equation where 112 is the first term times the common ratio 6 times. And then the third term, we get a value of 7. That's the first term times the common ratio twice. So for this one, instead of doing elimination with this system to find, because we're trying to find this and this to write the explicit formula, we don't know the first term of the common ratio. I'm going to create a system, and I'm going to solve it by setting up a ratio. So I'm going to put the bigger one on top, 112 over 7, and set that equal to our equation. So we're kind of creating a ratio with the two sides. So our a sub 1's cancel. I get 16 when I do 112 divided by 7. R to the 6th divided by r squared is r to the 4th. And when I fourth root both sides, I actually do get a plus or minus 2r. So we have two possible common ratios. So in order to find the first term, I have two different ones I could do. So if r is negative 2, we would do a sub 1 times negative 2 squared. And so then you get a value of 7/4, it looks like. And then we'll do the same thing with positive 2. And because we're squaring it in this scenario, we actually get the same first term, as we should. But you should be able to get it either way. All right, and then we have two different explicit formulas because we have one with a negative r. Oh, wait, I shouldn't have written. That's a sub n. One with a negative r, negative 2, n minus 1. And then one with a positive r. So here's both of them. Find the first term, find the common ratio. All right, it says find the 8th term. So I'm just going to kind of do both versions. Again, we're not necessarily sure based on our information what we got. So with the negative r value, I get negative 224 for the 8th term. And with the positive r value, I get positive 224. So we have to consider both options. And for now, both are true until we're told otherwise. Okay, feel free to pause if you need more time, but I'm going to keep things going. So on the back side, it's just kind of some additional problems. Sometimes we'll see sequences that don't have an addition-subtraction pattern or a multiplication pattern, and we have to be able to identify those. So these two say, given the sequence b sub n, find the first 3 terms as well as the 1000th term. So it's saying, can we find b sub 1 and just plug in 1 for n? So negative 1 to the 1 plus 1 times 3 times 1 plus 1. So wherever I'm seeing n, I'm plugging in 1. That comes out to be 4. The second term is the same thing. So 2 plus 1. And then 3 times 2 plus 1. That comes out to be negative 7. Again, you can use your calculator for that. Negative 1 to the 3 plus 1. 3 times 3 plus 1. You're going to get 10. Plugging in 3 for n. And then it also wants us to find the 1000th term. So I'll plug in 1000. And this you get negative 3001. So there we go. You can kind of just plug in n and get your terms. This next one's a little bit trickier because the first term is 2, and then they give us a recursive formula, and this one's a little bit different looking. So it says find the first 4 terms. Well, they gave us the first one, 2. To find the next one, this would be n plus 3, and this means the term before. So this would be the term before is 2. So that's 8. The third term, we have n, which is 3, plus 3 times the term before, which is 8. So I get 27. And then the fourth term, I have 4, plus 3 times the term before, 3 times 27, and I get 85. And then it would just, keep going from there. All right, last 2. Find the explicit formula for the following sequences. This one's a little bit weird because it's not necessarily perfect. Our numerator is going up by plus 2, and our denominator is going up by times 2. So we have an arithmetic sequence in the numerator. So we would write that as the first term plus the common difference, n minus 1. And then the denominator is a geometric sequence, so we could write that as the first term times the common ratio to the n minus 1 power. Or if you wanted to be more concise, you could just write that as 2 to the n, because the first term and the common ratio are the same. But there it is. So sometimes numerator and denominator will increase differently. And then this one has actually a pattern of n value squared, but it's alternating. So here's how we write that. So a sub n would be n value squared, right? Like 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. But then if we wanted to show that it was alternating, we want it to be times negative 1 to the n plus 1 power. We want the first one to be positive, so 1 plus 1 power. The next one to be negative, and so forth. So that's how we show alternating sequences, is we add this part. All right, last question. So this one makes you think a little bit. It says the common difference is 2. So we know D is 2. The product of the first and the sixth terms is 95 more than the sum of the first and the sixth terms. Okay, that's kind of a lot. So the product of the first and the sixth is, so that means equals, 95 more than the sum of the first and the sixth terms. Okay. So I need to solve this. It says find all possible values for the first term. So we're trying to find a sub 1. So first things first, we're kind of working with the sixth term. So I'm going to write the breakdown for the sixth term. It's the first term plus 5 common differences. And I'm actually going to sub that in. This is going to go right here. So I'll rewrite this. So a sub 1 times a sub 1 plus 5d equals 95 plus a sub 1 plus a sub 1 plus 5d. Okay, we also know that d is 2. So 5 times 2 would be 10. So I'm going to rewrite this one more time. And then I'm also going to distribute this in just to make it, a sub 1 squared plus 10 a sub 1 equals 95 plus 2 a sub 1 plus 10. Slowly working our way through. I'm actually going to rewrite this one to be 2a sub 1 plus 105. Just to combine it all. Okay. I'm going to get everything all on the same side. It looks like I'm rocking with a quadratic. So set it equal to 0. And then this is factorable with 15 and negative 7. Okay, so our first term, based on the information that we had, could be negative 15, or it could be 7. All right, there we go. That's everything.